Binary subarray with sum. Given a binary array nums and an integer goal, return the number of non-empty subarrays with the sum goal. A subarray is a contiguous part of the array. In example 1, we have nums equal to 1, 0, 1, 0, 1, and we have goals equal to 2. Okay, so how do we get to 4? If we look at this, then let's start at the very first element. If 1 plus 0, still 1, plus another 1, and now we have 2. So we meet our goal. We want exactly 2. All the subarrays with exactly the sum of 2. Let's add another one. Let's add the next element. Oh, well, it's a plus 0. We're still at 2. So that's going to be another subarray found. That's 2 subarrays now. Let's add this one. Oh, well, that's 3. It's too much. So we're going to remove one from the left. And these 4. But so we subtract that 1. Now we still have 2. Now we have 2 again. Because the 0 doesn't add anything, and these are both, it's 2 there. It's another subarray. And if we take away the 0, so now we have just that. That's still 2. Because the 0 wasn't doing anything in the first place. So that's 4 subarrays now. But if we take away this, then we only have 1 now, and that's 2 less. We want exactly the goal. And we're never going to reach that goal again. It's just going to keep going. So the entire point here, so here's how I think we should solve it. So for any problem that has a very specific constraint, so like an exact goal, not like below the goal or above a goal, and it's a subarray problem, there's a very specific way to solve it. Okay, you want to use a hash map plus prefix sum approach, and obviously you want to use you want to use a hash map plus a prefix sum approach. Okay, here's how you're gonna do it. Okay, so basically you're gonna keep track of prefix sum. So prefix sum basically means starting from the first element, you're just gonna keep adding at every element. You're gonna keep track of like a running sum from the beginning. So 1, 1, 2, 2, and that would be 3. Okay, so each time you kept track of like a running sum. Okay, and now so if we know exactly how much each element is adding, now what we can do is when we get to at any element, okay, so at any point, there's actually a pretty good diagram for this. So consult this. Yeah, consult this diagram. Okay, so in this diagram, we're at I. Okay, at I, the total sum is 14. In their example, they want 3. So if we want 3 and we are at 14, we want to find a number or a point in our subarray, or like in any previous subarrays, where the sum is equal to 11. So we would subtract our current from whatever we're looking for, which is 3. So 14 minus 3, that's 11. Well, since we kept track of a running sum, we'll see that 11 appears here after the 5, because 6 plus 5 is 11. So we'll remove that, and then we just have the sum of 3 left. And there's going to be just a similar idea to that when using a hash map. And the only way to really understand this is to like see it in action. So let's just code it. Cool. All right. So we have counter that, and then our sum, and we're also going to want the answer. We're going to want to create an answer variable too, because that's going to be the actual answer. We keep track of the amount of subarrays. Okay, so oh, another thing I forgot to mention, counter of 0 is going to be equal to 1. Counter of 0 is going to be equal to 1 because before the array really even starts, there's going to be an assumed 0 before this array starts. For any array starts, there's an assumed 0, because, for example, if the goal is 1 and you're at 1, well, you would need a 0 before it somewhere to get to that goal, which you do in all technicality have. You have a 0 before this. It's just a blank space. So you have to do this every time you do these types of problems with an exact constraint. Okay, so for items, what we're going to do first is add the sum. So sum is that, and then check if the number that we want appears in counter. So inside counter, we want is current minus I. Why is that? That's because if we take the current value, as you can see here, take the current value and we subtract I. The reason I said subtract I is because we'd subtract this amount. This would be I. Yeah. Right? Hold up. No, we wouldn't subtract I. Sorry, we'd subtract goal. Subtract goal because the current amount that we have minus the goal is going to give us the potential element that we're looking for, that if it exists, then we can get goal. Okay. And then finally what we're going to do is we're going to add the new element, counter of I, whatever that is, plus equals 1. It's not going to be I, by the way. It's going to be counter of sum, because it's going to be the sum that we're keeping track of, because we want to keep track of the prefix sum array. And then just return answer. Oh, there's going to be answer plus equals to that. If it exists, then we're going to add the amount of times that exists to the answer. And finally return answer. Cur is not defined. Okay, I used cur, right. It's going to be sum. I was using sum. And the runtime complexity is O of n, and an extra space is also O of n, because we're creating the hash map. And runtime complexity, I mean, we're just going through some nums. So yeah, that's going to be the answer.